Bismillahirrahmanirrahim. Hello again in practical number 4. This lesson will be about feed evaluation. Let's study together what we mean about feed evaluation and what we do. Okay, we can start with this question. Why do we test feeds before we feed the animal? It is important to test the feed before we feed the animal. Actually, the nutrient concentration can vary. They differ from each other considerably in feeds, especially forages. So because of that, we need to test the feeds to know the exactly nutrient concentration in certain feed or diet. Use feed test to target specific feeds to different livestock. As you know, the different species of animals they don't have the same requirements of nutrients. So you need to know the requirements of each type of animal, and also you need to know the nutrient composition of each feed to target the specific feeds to different livestock, to give each animal or each type of or species of animal the specific feed as they need to meet their requirements. Okay, so that will be by the feed testing. The third important of feed testing is use feed test to help determine what feedstuffs to buy for feed processing activities. Use feed test to help determine what feedstuffs to buy for feed processing activities, to choose which suitable for your activity, for your project, which suitable for your animal production. Okay, so you need to test the feeds to choose or to determine what feedstuffs to buy. Okay, what causes nutrient concentration to vary? As I said to you, the nutrient concentration is vary from feed to another, especially forages. So you need to test them before you use it as an animal diet. So what causes the nutrient concentration to vary? There is some factors affect these concentrations to vary in the feeds, such as plant species and variety. So as you know, the plant species are in animal nutrition there is so many plant species you can use in the animal feeding. So according to a different or a variety in a plant species they are different from each other. So according to this variety, the nutrient concentration is differ also. The protein concentration, the starch concentration, the fiber and toxins also are all various among these varieties. So you need to test each plant species to know what the nutrient composition of this plant species. Okay. Also, another factor is a maturity. As you know, the plants, when they get mature, like forages, when they get mature, the fiber concentration increases. The plant will be has higher fiber concentration when in mature. A fiber concentration is increases in mature plants. So the concentration of digestible energy and net energy will decrease because the fiber is difficult to digest by the monogastric animals. So when the concentration of fiber is increases, so the digest will be more difficult. So the digestible energy and the net energy will decrease, will be lower. The animal will get lower energy from this mature plant. So maturity is also a factor of nutrient concentration variety. The third factor is part of the plant. The parts of the plant also have a different nutrient concentration in the same plant. For example, the leaves in the plant contain more crude protein and digestible energy than other parts in the plant. So in the same plant, a part of the plant is also affect the nutrient concentration to vary. Another factors also harvest and good management techniques save the nutritive values. How this happened? The good harvest and good management techniques save the nutritive values. For example, if there is no harvest, a good harvest, the plant or the forages will lose the leaves, then we will lose some of the nutrient concentrations. Also, harvest and storage conditions. The storage conditions is also very important. That save leaves result more crude protein and energy. Okay, this about these two about related to the factor of part of plant. If you do a good harvest and good storage conditions, you can save the leaves, and as a result you save more nutrition or nutrient concentration such as crude protein and energy. If you don't do a good harvest or good management techniques, you lost some of the nutrient value of this plant. Okay. Another factor is a storage. As I said, storage is a very important part in the harvest. Good storage management that keep moisture content within a specific range and control the environment, temperature, sunlight, soil moisture and fertility, diseases, weeds, insects, they all result in safe nutritive values. That means when you control the storage, you can keep the moisture content and the nutrient content in the plant. Also, when you control the environment of the storage conditions, the environment such as temperature, sunlight, the soil moisture, and fertility, diseases, weeds, and insects. You also, as a result, you can save the nutritive values of the plant. So the storage is very important also to make the nutrient concentrations to vary. If there is a poor condition of storage, so you will lose the nutritive value of your forages. So this was about the factors affect the nutrient concentrations to vary. Now let's know the methods of feed testing. There is different methods of feed testing. The first one is a physical. This physical testing by using a senses: sight, smell, touch. You sight, you see this the forage or the grain or whatever the feed stuff was, and you smell if it had a bad smell or is it a normal smell, and touch it also. This test provide limited information, like this person. You use your sense and your experiences. This depends more on your experiences in feed testing, in physical feed testing. That means it needs some persons, they are expert in this physical testing, or they have more experiences in feed physical testing. They have they know, they have a knowledge about what the normal smell of the certain forage, what the appearance of it, the normal, if there is mold or there is a spoilage, or even if there is any metal, okay, and they touch it also. So here in this test, you just use your sense to know if this feed is good to buy it or to use it or not, okay, by sense. This is the physical method. Also a chemical method, this what we will study it today by using chemicals to analyze the chemical composition of the nutrient of the chemical composition of the certain feed stuff, okay. This gives this method is reliable and accurate, gives accurate predictions of animal performance, because you predict what if this will be good for the animal by this chemical composition will be good for the animal, so the animal will get a high performance, or it suitable for the animal or not, or if it meet the animal requirements or not. So it gives more accurate predictions of animal performance. Okay, this about the chemical method. Near infrared reflectance, NIR. This also analyze the chemical composition of the feed stuff, but by using the near infrared instead of the chemical method. They are analyzing the chemical composition of the certain feedstuff, but this chemical method using the chemicals in the laboratory, but this method by using the near infrared reflectance, by using a device in the laboratory by near infrared spectroscopy device. Okay, it gives also chemical composition and nutrient concentrations of the feedstuff. They both gives us the nutrient concentrations of the nutrient in the certain feedstuff. The fourth one is biological methods. The biological methods is or are two methods: in vivo, when you use it in the animal directly, when you use a feeding trial or feed experiment directly in the animal by using animals, feed the animal, and get the results of the experiment from this animal, so it's called in vivo. And in vitro method, when you act like what the happening inside the animal's body, but without using the animal, just in the laboratory. It's called in vitro. This image to explain what the biological methods for feed testing. This the in vitro method by act like what happening exactly inside the animal body. Okay, but in the laboratory without animal. But in vivo method, you use the animals directly. You feed them the certain feed stuff you want to test, and you get the result from this experiment. So you do a feed trials in the directly in the animal. So this is called in vivo method. So both of them are biological methods for feed testing. This important, the biological method is important to know the palatability of this feed, if the animal will love the taste of this feed stuff or not, if there is poisoning, okay, if this feed stuff is poison or any toxins, okay, that all will appear in vivo method when you use directly animals. Okay, it's very important. Okay, let's start to learn the chemical method to test feed or to evaluate the feeds. The common method to chemically test or evaluate the feed is proximate analysis of feed stuff. Okay, what's approximate analysis of feed stuff? It's a system for approximating the value of a feed or material for feeding purposes. It's approximating system of approximating the value of a feed or material for feeding purposes without actually using the feed in feeding trail. So we don't use the feed in the feeding trail actually, but just we approximate the value of this feed or the material for feeding purposes by analyze it in the laboratory without actually use the feed in feeding trail. Was developed this test is was developed at the Windy Experiment Station in Germany over 100 years ago. It based on the separation of feed components into groups or fractions in accordance with their feeding value. So this test or this system based on separation of feed components into groups or fractions in accordance with their feeding value. The various fractions are water, you know the percentage of water in this forage or this feed stuff. Also, you know the percentage of crude protein, the percentage of crude fat or ether extract as it's called in this test, the percentage of crude fiber, percentage of nitrogen-free extract, and mineral matter or ash as it's called in this approximate analysis. So this is the fractions of the feed components you will get by the end of the approximate analysis of feed stuff. So as I said, you will know the percentage of each fraction: moisture, ash, which is the mineral, crude fiber, crude protein, and crude fat. By the ending of the approximate analysis. So that's what I have got this picture to explain what's happening inside the laboratory to try to explain that as we was do in the laboratory previously. So this about the approximate analysis. Let's go further. What feeds should be analyzed? Okay. Analyze all feedstuffs that influence ration cost or animal performance. Important when potential differences between estimated nutrient composition and actual composition are great. So you need to know what the actually composition or what the actually nutrient concentration in this feedstuff. So you need to analyze it. Okay. So what the type of or what feeds should be analyzed? Forages. Nutrient composition varies greatly. As I said, they are differ from each other in the nutrient composition according to the source of these forages, according to the harvest management, according to the species, whatever. Okay. Also feed grains. It differs also according to the season, the geographical differences. They all may influence future purchases. Also, analyze byproducts. The byproducts vary considerably in nutrient and moisture content because they are differ in material and differ in sources. So you need to analyze it before you use it as animal diet. Always remember that always test non-traditional feedstuffs. Non-traditional feedstuffs. What I mean by non-traditional feedstuffs, it means all the uncommon feedstuffs using in animal feed, or we can say the type of feed or the feedstuffs not commonly used in animal feeding. So you need to analyze it, okay, before you use it as animal diet, because it's not a traditional feed stuff. So it's not commonly used as feed stuff. You need to analyze it before you use it as animal diet. Okay. Okay, let's know what's the nutrient expression. Okay, or how nutrient expression. Okay. First of all, let's explain what we mean by nutrient expression. We mean by nutrient expression is the nutrient levels or the nutrient presented, how it presented in feed, okay, or food analysis. Okay, so we expressed a nutrient in different situations. Number one is as fed basis. As fed basis means the nutrient concentration expressed as the animal would consume it, like fresh. Okay, so it will be containing moisture. Moisture means water inside the forage or the feed stuff. So it will contain moisture and dry matter and so on. So the sample will be fresh. So here in this situation, the nutrient concentration will be expressed as fed basis. So this is called as fed basis when the sample is fresh as the animal consume it, containing a moisture and dry matter and so on. Okay, well, when the sample is dried by the normal air conditions, so the nutrient concentration expressed as air dry basis, So in this situation we use a sample dried under normal air conditions without using the oven. Okay, so in this situation the nutrient concentration expressed as air dry basis. Okay, for example, the dry matter assumed to be 90% in as dry basis. Okay, the third situation, when we use the oven to dry the sample completely, then in this situation, the nutrient concentration will expressed as dry matter basis. So here in this situation, the nutrient concentration will expressed as dry matter basis. So this expression is most accurate, and it's common way to express nutrient levels. Why it's very accurate and it's commonly used? Because the moisture percentage is differ from plant to another, and also it can be differ from now and tomorrow, the moisture level in the same forage, right? So the accurate way to know the level of certain nutrient, such as crude protein or fiber, the accurate way is to express these nutrients as dry matter basis. Remember that, okay? So the nutrient concentration should increase when converting to dry matter basis. If you use a sample as air dry basis, say you analyze some sample of feedstuff as air dry basis, and you got a dry matter percentage as air dry basis without using oven, without completely dried. So when we convert this percentage as dry matter basis, means no moisture, so the percentage or the concentration of the nutrient, of this nutrient, will increase when converting to dry matter basis, because the moisture will removed and the nutrient concentration will be will increase. Why? Because there will be no water. Okay, the weight after we remove the water or the moisture completely, the weight of the feedstuff will decrease on dry matter basis. So because of that, the concentration of the nutrient will increase. I will draw it here, try to draw that to give you an example for that. If this is the feed stuff, okay, imagine that this is or this feed stuff weighing 5 kilograms, okay, containing moisture. This is moisture, okay, which are water, and this is the dry matter. The dry matter containing crude proteins, containing crude fibers, ash and vitamins, and all in the dry matter part, while the other part is moisture. So when you express the nutrient of crude protein, or let's crude protein in this 5 kilogram of feed stuff, while including a moisture also, the percentage will be, say, of crude protein will be for example was 18%, for example, and after we dry it completely using oven, that means after we express the crude protein levels as dry matter bases, so we remove all the water from the feedstuff, so the weight of this feedstuff decreased to, say, 3 kilograms. This is the weight of this feedstuff after removing the water. So there is no water here. There is no water here. This is just a dry matter. Okay, so here the concentration of the nutrients will increase, right? Because the weight of the feedstuff is decreased because we remove all the moisture from it. So here the nutrient concentration increases. The crude protein will be more than 18 in dry matter basis. Okay, this is just for example, just to explain or to imagine how it comes. Okay, so the better way or the most accurate way to express the nutrients concentrations is to as dry matter basis. Okay, if you it's better to use the oven to dry the samples completely and remove the water or the moisture completely before you start the analysis. And if you don't, you can, after you get the percentage of the certain nutrient, just convert it as dry matter basis after you get the percentage. Okay, I will show you how. Okay, we continue in nutrient expression. Okay, as I said, on dry matter basis, nutrient concentration should increase when converting to dry matter basis. Why? Because the weight of the feedstuff will decrease after removing the moisture. So the concentration, I'm talking about the percentage of the concentration of the nutrient will increase when converting on dry matter basis. As I said, the weight will decrease on dry matter basis. So here is an example. We have 2 kilograms of feed contain 10% of moisture. The moisture is the water inside the feed stuff. Okay, so 2 kilograms of feed contain 10% of moisture and 5% of crude protein. So we want to know the dry matter percent, and we want to convert the crude protein percent as dry matter basis. Why? Because this sample looks like it has fed basis because it has a moisture. As I said, as dry matter basis there is no moisture. Okay, we remove all the moisture completely by using the oven. So while this feed containing 10% of moisture, so this expression as fed basis or air dry basis, not dry matter basis. So we need to convert the crude protein as dry matter basis and we need to know the dry matter percent. Okay, the dry matter, how to calculate the dry matter percent? We calculate it by subtract 10% of moisture from 100%, because this is the total. As I said, the total percent of feedstuff containing dry matter and moisture. So when you have when you know the percent of the moisture, then you can easily calculate the dry matter. So 100 minus 10 equal 90%. So this is the percentage of dry matter of this 2 kilograms. So this 2 kilogram of feed containing 90% of dry matter, okay, and 10% of moisture. Now we want to know the dry matter, the amount of dry matter in kilogram. So how we do that? By multiplying the percent of dry matter by 2 kilograms to get the amount of dry matter. So the amount of dry matter in kilograms, dry matter kilograms will be 2, this is 2 kilograms, multiplying by 90%. 90 divided by 100, because it's a percentage, okay, equal 1.8 kilogram. So here you can see the weight is decreased when we convert it as a dry matter base, right? It was 2 kilogram when it was including a moisture. After we remove a moisture, or after we calculate it as dry matter basis, the dry matter, the weight of the feed being 1.8 kilograms, so it decreased, okay. So 1.8 kilogram of dry matter, including all the dry nutrients inside without moisture. Okay, then we want to convert the crude protein percentage to a dry matter basis. We want to convert it from a fat basis to a dry matter basis. So how we'll do that? We will first calculate the total amount of crude protein in this 2 kilogram of feed. The total amount of crude protein in 2 kilogram of feed is multiplying by the 5% of crude protein by 2 kilogram, as we did in the dry matter. So 2 kilograms multiplying by 5 divided by 100, because it's a percentage, okay. So 2 multiplying by 5 divided by 100 equal 0.1 kilogram. So this is the amount of crude protein per kilograms in the feed, okay. So we want to convert the crude protein concentration as dry matter basis. Then after we know the amount, not a percentage, the amount of crude protein in kilogram, so we can calculate the crude protein on dry matter basis by divided the amount of crude protein in kilogram by the amount of dry matter of feed. So 0.1 kilogram, which is the amount of crude protein in kilograms, divided by the amount of dry matter in kilogram, will give 0.056. This value we multiplied by 100 to give us 5%, 5.6%. This is the percentage of crude protein on dry matter basis. So you can observe it, the crude protein percentage increased from 5 to 5.6 percentage because we converted to dry matter basis. Okay, instead of this long way, I can give you another way, direct, to calculate or to convert the crude protein from fed basis to dry matter basis. You can do what? After you know the dry matter percentage, you can just divide it 5% or the certain nutrient concentration divided by the percentage of dry matter. So after you convert it to a decimal, like 0.90. Okay, why I did it like this? Because it's a percentage. I can't make it 5 over 90 over 100. Instead of that, I wrote 5 over 0.90 because it's a percentage. Okay, will give the same result, will be 5.6 percentage. This is the crude protein percentage on dry matter basis. Okay, so this is direct way to convert the expression of some nutrient concentration from a fed basis to a dry matter basis by using a dry matter percentage. Okay, or you can use the weight of a dry matter and then try to calculate the weight of crude protein in total feed, and then follow these steps. But if you need to calculate it directly, you can use this formula. Now you know the key rule here is the nutrient concentration should increase when converting to a dry matter basis. Okay, let's go further. Now we will going to start to the determination of each nutrient in the feedstuffs. We will starting by dry matter determination. Actually, we were doing this determinations in the laboratory by using the tools and the oven, but now it will be as theoretical. So determination of dry matter in the feedstuffs. Before we start determination, you need to remember to follow the proper procedures in obtaining and preparing a sample, as I told you. That's essential for an accurate analysis on given lot of feed. Okay, the objective of the test is to determine the dry matter of feedstuff. The equipments: the oven, the dryer oven, the crucible, sensitive balance, and desiccator. I hope you remember these tools. I think I have show you on the practical number 1. This is laboratory equipments. Okay, so the equipments we need in this test is our oven, crucible, sensitive balance, and desiccator. Okay, the description of the test. First, the crucible will be weighed to 4 decimal place. Then about 5 grams of feedstuff will be weighed. Now we have two weights. We have weight of sample, which is about 5 grams, and the weight of crucible, which is empty. When it was empty, first you weigh a crucible empty, then you take 5 grams of the feedstuff or of the sample and weight. Now you have two weights. Okay, then the crucible plus sample of the feedstuff will be put in the oven. So you will put the sample on the crucible and you put it on the oven for overnight, 18 to 24 hours. Then the crucible, after this period of time, then the crucible and the remaining of the sample will be put in the closed desiccator to cool at the room temperature. Then crucible plus the remaining of the sample will be weighed. Okay, this will be the third weight, right? First we have a weight of the crucible empty, and then we have the 5 grams or the weight of the sample, and then the third one is the weight of the crucible plus the remaining of the sample after drying. Okay, they all should be documented. Okay, now the calculation. It's very simple. To calculate the dry matter content, just follow the equation. Dry matter percentage equal the weight of the sample after drying divided by the weight of the sample before drying, all multiplying by 100 because it's a percentage. Okay, to calculate the moisture content, water or moisture percentage equal 100 minus dry matter percentage. Okay, let's take some examples for that. Example, we have forage that we want to determine its dry matter content from the following information. Okay, here is given information about this forage. The weight of the crucible the used is marked by W1 equal 2.455 grams. Okay, the weight of the sample is marked by W2 equal 2.011 grams. This is the sample before drying. Okay, then the weight of crucible and remaining of the sample after drying is W3, 4.231 grams. So to calculate the dry matter content, we have to do the formula, which is the weight of the sample after drying divided by the weight of the sample before drying multiplied by 100, right? But we have here some problem. The weight of the sample after drying is containing the weight of crucible also, because they are together. Okay, the weight 3, W3, the crucible and remaining sample after drying, they are combined together. So how we divorce them? By subtract the weight of crucible from this. So we want to follow this equation. The difference in weight W3 minus W1, W3 containing the weight of crucible plus the weight of sample after drying. Okay, this W3 minus W1, which is the weight of crucible empty, then will give us the weight of sample after drying. Then we divided the weight of sample after drying by the weight of sample before drying, and then multiplied by 100 equal this. Okay, that's what we did in these equations. So the weight of the W3, which is the weight of the crucible, and the sample after drying 4.231 minus the weight of crucible empty 2.455, then divided by the weight of the sample W2, which equal 2.011, and then multiplying by 100. So the dry matter is 88.31%. And to calculate the moisture content, just 100 minus 88.31 equal 11.69%. I hope it's clear. It's very simple. Another example. If we have 3 grams of forage, 300 grams of forage, and its dry matter percent is 90%, and we want to know its dry matter content in amount. Here we want to know a dry matter content in amount. We know the percentage of dry matter. Okay, just we want to know the amount of dry matter as the example I gave you. So just you need to multiply the percentage of dry matter, which is 90% or 90 over 100, multiplied by the amount of grams of forage to give you the amount of dry matter. Okay, so the amount of dry matter is 270 grams. And then if you want to calculate the amount of moisture in grams also, you can subtract 270 from 300, which is the total of grams of forage, to give you a 30 grams of moisture. It's also very easy. I think that's about the lesson for today, the determination of dry matter and the field evaluation. We will continue on approximate analysis for the new lessons, and we will study them all the groups of nutrients, crude protein. Now we study the dry matter determination. So we also will study the crude protein determination, crude fiber determination, ether extract and fat determination. Okay, so in several lessons. Now, if anything not clear or any question, please feel free when you ask me. And thank you and bye bye.